Everyone should have made it to this point where you have a new folder called Iris. You made a copy of your basketball script, and then you also have the Iris data. Okay, so we can open it up just to make sure it's there. Okay, and so yep, there is our data. And so let's begin. We're going to go into this copy. We worked so hard on this first one because it's going to make our lives so much easier. So the first thing we're going to do is we're going to do the perceptron, but instead of the basketball data, we're going to apply it to this iris, the flower data, okay? And we can get rid of this copy. So most of you guys will be doing this on Thursday. So you're going to be at 6:21, and we're going to hit rename. Okay, so the deal with this is we're going to import the same libraries and everything, so that's fine. That's fine. Let's run that. It's all going to be the same. But here's what's going to start different. We're using different data. We're using the iris data, okay? So instead of basketball data, you change it to the file name of iris data, because as you see here, that's what it's called. Okay? So let's run that. Let's make sure it's run. Well, boom. Okay, awesome. So that's the new data. We run the next line. That's the new data. Okay, so what we're going to do is we're going to do petal length and petal width. Those are the two types of attributes we're going to look at in order to make our sort of classifier. So we're going to change label 1 to petal length, and we're going to change the other one to petal width. All right? Cool. Let's run that. That doesn't print out anything or anything, so nothing comes out. But now what we need to do is we kind of need to change. You see how it says iris setosa, iris virginica, I'm going to say. I'm not a flower expert. I'm guessing that's how you say it. So remember, we need to change all words to numbers or else it'll mess up our learner. So watch this. Here's a trick. You can open up your data. The first type is, let's go, iris setosa. So I'm just going to copy that, Control-C. And then instead of, we're not doing all stars and not all stars, so I'm going to make the iris setosa the 0 one. Okay, and then it looks like the next type, oh, iris versicolor. I think that's how you say it. I'm going to replace that for all. So that's going to be mapped to 1. And watch this. But we have a third type. So our third type is iris virginica. Okay, so I'm going to copy that and put that right there. And I'm going to map that to 2. Okay, let's run that. Okay, cool. Look, it changed all the ones that were iris setosa to 0, and that's what we wanted. And then I'm assuming it changed all the other ones. Watch. We could even add, we could even check the ones at the bottom. So df numbers dot tail, and let's run this. Yeah, so watch this. It changed all the iris virginica. We mapped it to 2, so it changed it to 2. Perfect. All right, but now we need to tell the computer where our data columns are and where our output column or our class column is. So remember, it's 0 base. So the first column is 0, second column is 1, third column is 2, 3, 4. So we want these two, so 0, 1, 2, and 3. That's where our data is, so we're going to put 2 and 3. And kind of our output class column is 0, 1, 2, 3, 4. That's in 4. Boom. All right, so we have made all the changes to do a new type of data set. So now we go down here, and then this is where we would change it if we wanted a different type of learner. But watch, we want to use the perceptron. Perfect. So look at this. We just go to kernel. We're going to run everything over again, but this time it's going to be for the iris data. So let's see what it comes out to be. See. All right, cool. So let's go. Let's give a refresher on what happened. So look, remember, it standardized the data right here, converted between the number of -3 and 3. It split it up into training data and testing data. We made our learner, and then we used the training data to make predictions. And let's see how close. The predictions on the training data weren't great. 62%. We had 40 misses. Is that so? Look, obviously you can see that if you want to zoom in. Look, all these X's that are in the green spot, those are misclassified. All the reds, look, all the reds that are in the blue, those are all misclassified. Oh, that's bad. And so look, in the testing data, we scored a 60. So overall, that's how it is. So again, we missed all the reds in the testing. So this was our final output. We have circles around the testing data. And so boom. We didn't do that well, 61. Well, watch this. What we can do is we can come up here and we can change the parameter value. Let's add a 0. This just makes the computer go more and more over over the data, like practicing more. So you go to kernel, restart and run all. Let's see if that ups our percentages. All right, whenever it's kind of jiggling around like this, you know it's working. It just takes a little longer because we said, okay, go over the data more. Boom, actually that worked a lot better. Look, training, we had 89%. Look, it classified all the reds correctly. Kind of misclassified some of the blues, but not too bad. 80% on the testing data. Look, got all the reds, got all the blues, got most of the greens, but some of the blues are leaking out. And so this was overall. Let's try adding, maybe one more zero might help. Let's see. Okay, this will take a lot longer than the other one. So we just got to be patient. Let's see. You can talk to your friend. Start thinking of life goals while you're waiting. Play tic-tac-toe. All right, it's good. Uh-oh, we went the wrong direction. So look, by giving it an extra zero for that parameter, our training data only was 75% accurate. Because look, we got a lot of the blues and the red. That's bad. 71% on our testing data. A lot of the blues again are in the red, and so accuracy only 74. So what's really cool about this code and something that I've written for you is it automatically outputs your results. So look, you can kind of review it. So when your parameter was 1,000, your final results were 61%. But when you added an extra zero, it looks like 86% was your overall success rate. When you added another zero, it kind of went the other way. Because what we're going to do is we're going to compare it. So that was with the perceptron. So our best was kind of an 86. And we're going to compare it to the other type of learners and see which one gives us the best percentage. So what you can do now is you can exit out of this guy. And you can exit out of this. Exit out of this as well. And we are going to, watch this, click that right there and hit duplicate. We're now going to create the logistic regression learner. And all the hard work we put in on Wednesday, when you guys made the first one, you just get to edit it a little and it'll work. Watch this. So number one thing we always need to do is change the title. So again, we don't need this copy thing. It just automatically makes that for us. And we're going to change, instead of the perceptron, we're going to change it to be, let's see, logistic regression. Okay? Okay. And so the way to do this, there's a couple changes. The only thing we need to change, we're still using the same data, so we're good to go there. The only thing we need to go and change is the name. So we need to change this to logistic regression. We're going to change this to, we're going to just put 1,000. The name of this, the parameter is C. And we need to change, instead of using the perceptron function, we need to use the logistic regression. I think that's the right one. Okay, so everything else is exactly the same. So what we can do is we go to kernel, restart and run all, and let's try it. Okay, whenever it's bouncing like that, you know it's working. Sort of crunching your numbers. All right, so remember, the logistic regression as well uses straight lines, but it does it sort of a different method. And look how, watch. Okay, we made a logistic regression. Nice. Our training data, oh, we only missed 4. We got a 96 on our training data. And look, because it made some kind of straight lines. Like it probably only missed this X. A couple of those greens, maybe, are the only ones it missed. Our testing data was 98. Wow, that's pretty good. Look, it only missed, I think, that one right there. That's kind of cool. So total, we got a 97% accuracy, and that's what it looked like. And if you go right here to the results, look, we can see how it's stacked up against the perceptron. So when we ran the logistic regression, our final one was a 97. That's higher than we ever got with the perceptron. So just for, to try it out, let's try changing the parameter value. Instead of 1,000, let's do 100. Okay. Let's restart and run all. Let's see if that makes a difference. Let's see if it was better or worse. Okay. Looks like it was about the same. All right. Interesting. Let's try changing it to 10. Let's see if that's going to make a difference. It could either be better or worse. You see how the lines are different? That's because the parameter is different. Again, this looks like it was a little worse. Our final one was 95, okay? And if you can see here, you got to exit out in order for it to update, and then you reopen it. Yeah, so when we made it our parameter of 10, it came out to be a 95. And in the training, it was 94, and on the testing, it was 90. So it looks like these two are our leaders so far. So we come over here. We are done with that. Oh, let's cancel. Let's save it. File, save checkpoints. All right, boom. We can exit out of that. And we're going to do the same thing, but we're going to create an SVM kernel this time. That's the one that can draw kind of squiggly lines. Okay, we come here. We're going to do the exact same things. All you got to do is, look at this. You go to, it's going to change the name. You don't need this copy. We're going to do an SVM kernel. SVM kernel. Okay? Again, we did all the hard work. We made our code. It's still the same data. We're just applying a different learner, so the only thing we need to change is right there. So we are going to change this to the SVM kernel. Remember, we're going to do lowercase kernel. We're going to create the same parameter of, we'll start with 10, actually. And we'll do C. And then we need to change this guy to SVM kernel, because we're going to use the kernel function. And everything else is the same. So let's go and let's restart and run all. So let's see if making sort of squiggly lines to separate the data can help. Okay? It's running. All right, look, that's some squiggly lines right there. So let's check it out. So training data, it did all right, 95. It missed about 5. So like you see how some of the greens are in the blue spot? It missed those, and one of the blues is in the green spot. Okay. Testing, it did pretty well. It only missed 1, so it looks like the only one it missed is this green one that should be in the green, but it classified in the blue. So overall, it got a 96. Still not better than our 97 though overall. Let's see if we adjust the value. Let's change it to 100, and let's run it. Let's see if that helps at all. Okay, so remember, different parameters lead to different lines. This one again, 95. Ooh, this was perfect on the testing data. So overall, I got a 97. It tied our highest score. Let's see if we can do one better, and let's go 1,000. Because the different parameters, all it is, it's kind of like a tuning fork. Like you just tune it like you do an instrument, and it might be better, it might be worse. For those of you who play instruments. This one, it looked like our final was a 97, okay? So it missed 1 in the testing data, but it got a little better in the training data. So the last one we're going to look at, let's save it. Let's make a copy. And then we are going to call this, let's see, we're going to open up our copy. This one is going to be the decision tree, what we should have learned about in class. So we're going to change our name. Let's change this one to be the decision tree. Okay? And so this one is a little different. Whenever it's a tree or a forest, you got to do one special thing. Okay? So you got to come down here, and when it standardizes the data, these do not need to be standardized. So we're going to comment this one out. We don't want to standardize it. And look, we just want to keep it old regular X. So we kind of activate that guy. Okay? That's the only thing we need to do for decision trees and random forests, is that it's different. And then we just do the same thing. We just change this. We are going to write the name, which is decision tree. Decision underscore tree. Okay, this one, the type of parameter is called the max depth. And we're going to change that to 2, okay? And then we need to change this one to use the function decision tree. Everything else is the same. You go restart and run all. let's see. And remember, decision tree kind of used boxes and rectangles to sort of divide its data up. Let's see how it did. Okay, so this was the training data. Not bad, 96%. This was the testing data. Not that great, 91. So overall, look, it uses these lines. Overall, it got a 95, okay? So let's try changing the parameter a little bit. Where are we changing? Up here. Okay, let's try changing the max step to 1. Okay, let's see if that helps. Restart and run all. Okay, let's go look. Not well at all. 70%. Look, it didn't even make a blue section. That was bad. Whoops. And so overall was 67. So let's go the other direction. Let's go 3. Okay, let's see how this does. It's going to take a little longer the higher the parameter is usually. All right, let's see how it did. Okay, training data, 98. Wow, that's pretty good. Testing data, 98. So overall, we had 98. That's pretty good. That's our highest one yet. So just to even check, let's try 4. Okay, let's see how this one does. So let's see. Training data, 98. Testing data, 98. Okay, and total 98. So if we look here, we can exit out of here. Oops, I always forget to save it. And another way to save it, just click that right there. That saves it. So we look at our results. Look, this will show you which learner did best with which parameter. And so look, the highest number we have is about our 98, okay? And that was with the decision tree using either a max depth of 3 or 4. There you go. That was kind of a look at some of our first learners. We're going to do the next 3, and then